As we start looking at the application of trigonometric ratios, we're going to be able to look at angles of elevation and depression to do indirect measurements of distances and sizes. So with this, we have two basic types. We have angles of elevation and angles of depression. An angle of elevation is the angle at which a person looks up at to sight the top of an object. An angle of depression, therefore, would be the angle at which a person looks down at to sight the bottom of an object. So depending on where you're at and what the object you're looking at is, the angles that we call can be different pieces. In the diagram here we have an airplane that is flying and sights a mountain in the distance. Now from the airplane's perspective, it has an angle of elevation, angle 3, to sight the top of the mountain. It has an angle of depression, angle 2, to sight the bottom of the mountain. Using parallel lines from the path of flight of the airplane, the top of the mountain horizontal to the ground, and the ground itself, angle 4, if you're at the top of the mountain, you'd look down, that's an angle of depression, to sight the airplane. Or if you're at the bottom of the mountain, angle 1 would be an angle of elevation to sight the airplane. Angles 1 and 2 are congruent to one another based on alternate interior angles of parallel lines with a transversal. Angles 3 and 4, by the same argument, are congruent because of the parallel lines and the alternate interior angle theorem. So we can use these relationships and our trig ratios in order to solve for missing distances. So we're going to take a look at a couple of such examples in this lesson. Let's take a look at our first example. A surveyor is locating the position of where a new landmark is to be placed in relation to the corner of the street. The surveyor is about 6 feet tall and is using a device called a sextant to measure the angles. The angle that he is looking down at the location is 20 degrees. How far away is the placement of the landmark? So let's take our diagram here and add a few pictures or items into it. So he is compared to the horizontal as best as I can. He is looking down at where the landmark is to be placed, and his angle of looking is 20 degrees. His height is 6 feet tall, and we're wondering how far away the landmark is to be. So since he's 6 feet tall here, the distance on this side is also 6 feet. And then we can use our trig ratios to find that distance. This angle here will be 20 degrees, and what we're basically looking for is how far this distance is in relation to that. Well, if we pull this diagram aside, what we have is this basic piece, right angle, 6 feet tall, 20 degrees, and an unknown distance to the landmark. So what we're looking at here is a situation that will use the tangent function, since we are looking at the opposite side and the adjacent side, or the opposite leg and adjacent leg. So pulling in our trig relationships, we will have the tangent of 20 degrees is equal to 6 foot over x, and we need to solve for x. So basic idea, when you have your variable in denominators, we take your variable and whatever's on the other side, and they simply trade locations. So x is going to equal 6 foot divided by the tangent of 20 degrees. And simplifying that, we will come out to x being approximately 16.48 feet, or rounding off 16 and a half. So it's going to be about 16 and a half feet from the corner to the location of this landmark, a monument, a sign telling welcome to a park, something like that. So we can use this to survey distances, and it's used quite often in construction and building trades. But let's look at it from a more tourist perspective and enjoyment. A businessman is arriving by helicopter at Burj Al Arab in Dubai, lands on top of the 321-meter tall building, and looks out over the city. In the distance, he sees the tallest building in the world, Burj Khalifa, with its amazing height of 828 meters, where his business meetings will be being held. He is looking up at an angle of about 2.7 degrees. How far is it between the buildings? So, looking at our perspectives here, right here we have Burj Al Arab. Burj means tower. Out on the end is this little shelf, and that is a helicopter pad for businessmen to be able to arrive for their hotel stay. The city lies out, and out in this distance is this building. This is Burj Khalifa, and the top of the tower is 828 meters. So how far are we looking in order to see this building? Well, we have to do a number of side problems in order to come up with this. So if this building, Burj Khalifa, is 321 meters, and this if Burj Al Arab is 321 meters and Burj Khalifa is 828 meters, what's the difference in height? That's going to help us build our formula. So we take 828, we subtract the 321, and we come up with a difference of height of 507 meters. So from the top here, looking out, we have a difference, and this drawing is not to scale by any means. Our difference is going to be 507 meters. And this angle that's being looked up at is 2.7 degrees. And we want to know what this distance between the buildings is. Again, we're going to be using our tangent function and finding that distance. Now the distance that comes out is going to be in meters, and it is going to be a very large number since 2.7 degrees is a very small angle of elevation. And what we're going to have to do is convert our final meter answer into kilometers, and we'll get a rough estimate of how far it is between these two buildings. So we take our tangent of 2.7 degrees, and that's going to be equal to 507 meters divided by this distance. Solving similar to what we did previously, we have d being equal to 507 meters divided by the tangent of 2.7 degrees. And running the calculations real quick, we get a rough estimate of this distance being 10,750 meters. Now converting that into kilometers, that comma just turns into a decimal point, and we're looking at about 10 3/4 kilometers between the buildings, or roughly about 6.8 miles. So these two landmarks in one of the fastest developing cities in the world are about 10 3/4 kilometers apart. So we can use these angles of elevation and depression in order to find a lot of distances indirectly. You can survey the tops of mountains, find distances between objects that you know their height differences of, and a lot of other such items. So make sure you have these examples down and are ready to use them as we move forward.